If you look at the planets in our solar system, everything seems remarkably calm. We orbit the sun in a predictable, stable clockwork routine. But zoom out past our local star, and that stillness falls apart. The entire Milky Way galaxy is currently tearing through the intergalactic void at 1.4 million miles per hour. And we aren't traveling alone. Andromeda, the Triangulum galaxy, and dozens of our galactic neighbors are all hurtling along the exact same trajectory, locked onto a specific, shared destination in space. For decades, we had no idea what we were falling toward. Our line of sight is completely blocked by the thick band of gas, dust, and stars sitting right in the center of the Milky Way, a dense veil astronomers call the Zone of Avoidance. Our entire cosmic neighborhood is essentially being dragged blindfolded across the universe. To figure out where we're going, we have to calculate what kind of invisible engine possesses enough gravitational muscle to haul thousands of galaxies across the void. Modern radio and X-ray telescopes gave us the first real look through that blind spot. Because these specific wavelengths pass right through the dense dust of our galactic center, astronomers could finally map the structures lurking on the other side. This 3D topographical map shows our cosmic neighborhood, the Laniakea Supercluster, a massive web of 100,000 galaxies. Instead of a single black hole, Laniakea is a basin. Galaxies flow along invisible veins toward the lowest point, the Great Attractor. But a data chart reveals a mathematical problem. The Great Attractor simply doesn't contain enough matter to pull the Milky Way at 1.4 million miles per hour. If you are sprinting toward a finish line faster than your own legs can carry you, a secondary force has to be pulling you forward. Since the local gravity in our immediate valley isn't strong enough to account for our speed, we have to look further out. The Great Attractor and the Laniakea Supercluster aren't the primary engines of our movement. They are just stepping stones caught in a much larger gravitational current. To find the source of that current, we have to scale out far beyond the borders of Laniakea and examine the wider intergalactic landscape. Out here, our supercluster is dwarfed by an even denser mass, the Shapley Supercluster. This overwhelming collection of thousands of galaxies actively drags Laniakea and the Milky Way toward it. When combined, the math makes sense. Shapley pulls Laniakea, and Laniakea pulls us, creating a massive compounded forward velocity. Yet, even when astronomers factor in the greatest known concentrations of matter ahead of us, we still fall short of that 1.4 million mile per hour drift. We are missing the second half of the physical equation. The answer isn't found by looking at the dense clusters ahead of us. We have to look at the seemingly empty space directly behind the Milky Way. This 3D spatial map highlights a colossal cosmic void known as the dipole repeller. Sitting at our backs, this massive region is practically devoid of all matter. Because this void lacks mass, surrounding regions are infinitely denser. That steep difference creates a powerful push, aggressively repelling our galaxy away from the emptiness. It takes this exact physical combination to flush our galaxy across the cosmos at such a breakneck speed. We are experiencing the ultimate pull from the superclusters ahead of us and the ultimate push from the void behind us. With these forces locked in place, the Milky Way is set to continue this inescapable journey for billions of years. Which raises a fairly immediate existential question. Is our entire cosmic neighborhood destined to slam into a dense graveyard of overlapping galaxies at the center of the Shapley Supercluster? The answer is dark energy, an opposing force accelerating the expansion of space. This outward stretch fights the inward gravitational flow of the Shapley and Laniakea superclusters. Dark energy wins the tug-of-war, expanding space faster than gravity, snapping cosmic connections and isolating our galaxy. We have spent decades mapping the intricate push and pull of the cosmos, finally learning to read the currents of our universe, just as those same currents are destined to disappear forever.